Hello everyone, welcome back to From Root to Best. Most coding interviews don't fail you because you don't know data structures. They fail you because you make dangerous assumptions. I've seen candidates solve the problem, write clean code, and still get rejected. In this video, I'll show you 5 very common mistakes that good coders make in interviews. And I'm not talking about beginners. I'm talking about good coders. If you have ever thought, I solved the problem, I don't know why I failed, this video is for you. Without any further delay, let me start with the first and most common mistake. Most candidates know BFS and DFS. That's not the problem. The problem is knowing when to use which one. Suppose the interviewer asks, find the shortest path. DFS can find a path. BFS guarantees the shortest path. When you choose DFS here, the interviewer doesn't think you forgot BFS. They think you didn't understand the core requirement of the problem. Interviews don't test how many algorithms you know. They test how you choose. Let me quickly show you a sample code for this mistake, which will make you understand the problem very easily. Here, to save some time, I already have created this class DFS sample test. In this class, we will write our solution to find the shortest path of the unweighted graph using DFS algorithm. So please be with me while I finish writing the code. Okay. So initially I will initialize or I will declare some variable. So this is our visited array, just to mark the nodes visited or unvisited, right? And then I will have a minimum path variable just to check which path or which calculated path is the minimum one, right? And since it will contain the minimum path, I will assign it to with the maximum value, right? Now let me write our method. So here I will use the recursion to find the solution, or in other words, to find the shortest path between the source node and the target node. Okay, so I hope you are aware of what a recursion is. If not, please let me know in the comment. I will prepare a dedicated video where I will explain what recursion is, okay, with lots of examples, of course. So this will be our method, and this method will have parameters like, first of all we will have the graph itself. Okay, so here I am using a simple graph, so it will be integer nodes, so all the nodes will contain the integer value just to identify different nodes. Okay, graph itself. So let me have this. Then we will have the current node, right? So let me write it as current. Then we will have a target, and finally we will have depth. Okay, so yeah, so this will be our shortest path finding method, and we will call this method again and again in recursion mode to find the shortest path between the first source node and the target. Okay. Okay, so let me first add our base case here, right? So whenever we are writing anything using recursion, we must first take care of the base case always. That's the first rule of using recursion, right? So if our current is equals to target, that will be our base case. We will simply calculate the mean path. Mean path will be simply the minimum value of current mean path and the depth. Okay, so to find the minimum, I'm just using math dot mean function. Okay, uh, mean path comma depth, right? And then we will return this mean path. Okay, so this is our base condition, and now we will have our logic. So first we will update our visited flag so that we don't consider the node twice, right? So this visited of the current node is true. Next we will take the child of the current node, right? So will be, let's say, neighbor of the graph dot get the current node, correct? And since it's DFS not BFS, so instead of first going through all the child, we will keep going deeper of child nodes, right? So that's why it's DFS. So here we will simply first check whether this node is visited or not. So if not visited, the neighbor node, then only we will move forward, right? And here we will calculate the result. Result will be calling the DFS function again with the graph. Current will be neighbor and target will be our existing target only, and depth will be current depth plus 1, right? And I will check if result is not equals to, sorry, -1. That means if it finds any minimum path, if it not like that it couldn't find, then I will simply return the result. Okay, now outside of the for loop, I will simply return -1 in case of if the target is not findable. I mean, let's say we have given an invalid target, so we have traversed through all the nodes but couldn't find the target. That case, so and all the nodes are visited. That means we have traversed through all the nodes, right? And we couldn't find the target. So in both the cases, we will return -1. Now let me quickly write the main function that will call this method, right? So public static void main. Here we will have our arguments. So first of all, I will basically define my test data for graph, right? So here I will say, as I said, I will simply have a, integer graph which will have different nodes with different integer values, right? So let me quickly define this. I will use list of method here to initialize it. Okay, list of, let me quickly initialize it, then I will show you how our graph is supposed to look like, right? Then finally list of this. Okay, so the graph I have defined here, it will be look like something like this. Just simply paste it. So uh, the graph will look like something like this. So initial node will be 0. Okay, and 0 will have two children, 1 and 2. Now 1 will again have two children, 3 and 4, and 3 will be connected with 6, and 4 is the dead node, dead end we can say. I mean, it's not connected to any other node apart from 1, okay, edge node. Or then from 0 to and 2 will be connected with 5, fifth node, 5 node, and then 5 is also connected with 6. Okay, so here as you can see we will have two paths to reach. Let me first give you call here. Okay, now let me initialize our visited array, right? So visited will be our boolean array, right? So new boolean and array basically of size of the graph, correct? Now I will simply call our DFS method, right? Graph is the graph we have initialized. First value or initial value will be 0. Target will be, let's say we need to find we need to reach to 6, number 6 node. Okay, so 6, and depth, initial depth will be 0, right? Now let me print the result. Shortest path, sorry, result. Okay, now here current, so initial will be 0 and we need to reach to 6. So with this graph we can see we will have, or we can have two possible paths, right? So path 1 is from 0 we will go 1, then from 1 we will go 2, then finally we will reach 3. So total level we will have 3, right? And path 2 also, from 0 we will go 2, from 2 we will go 5, and from 5 we can reach 6. Here also we will have 3. So shortest path to reach from 0 to 6 is 3. So now let us quickly test our code. Okay, so let me run this main method. Yeah, so as you can see, shortest path is resulted in 3, right? Now let me quickly write the solution using BFS. Okay, so just give me a second. Let me open a new window, right side window. I will write the same solution using BFS algorithm. Just to save small time, I have already created the BFS sample test class. In this class, I will write my method to solve the problem. Okay, so let me first create the method. BFS shortest, sorry, test path. Okay, and here I will not use recursion. Here I will use simple while and for loops to iterate over all the nodes and find the shortest path. Okay, now this method will also have some arguments. So first argument will be same as DFS, it will be our graph. So I will have list of integers. Okay, and graph, right? Next we will have our start. So since we are not using recursion, I will not use current, I will use start. Okay, and our target value, correct? Now coming to the method, here I will use queue to iterate over all the nodes. Why queue? Because queue basically follows the FIFO algorithm, right? And in BFS we need the to traverse through the breadths. So the first child nodes which is detected, we will go by that breadth only. That's why we are using queue here. Okay, so Yeah, and also we will have a visited boolean array. So new boolean of size graph dot size. Now here I will first push our first element, the start element, to the queue, right? And also I will mark the first element or the start node as visited. Start equals to true. Correct. Now I will initialize level. So since we are not using BFS, we will not use the term depth, we will use level for BFS. And now finally we will loop through till our queue is a queue has some element. So till the queue is not empty, right? Here I will check the elements of the queue, that means the child node, right? Then I will loop through all the child nodes first. That's why first for loop is with the breadth or size of the queue. Int I equals to 0, I less than size, I plus plus. Clear? Here I will get the node from graph, sorry, not from graph, we will get the node from queue dot poll, right? And I will compare if node is equal to target. If that's the case, we will simply return our current level, right? And later, if it's not equals to target, now I will get all the neighbors of the selected node. So, sorry, int neighbor is equals to graph dot get node, and I will check if this node is not already visited, right? So not node, neighbor, sorry, visited neighbor. If it's not visited, I will mark this neighbor node as visited, and I will add this to queue, correct? Yeah. And after each breath iteration, I will simply increase the level by 1, right? And after all the visit, I mean once I traverse through all the nodes of the graph, connected nodes, if I couldn't find the target, I will simply return -1. Yeah, so this is our solution to find the shortest path of unweighted graph using BFS algorithm. Now let me quickly write the main method. Let me copy the entire main method and then I will modify. Okay, so I have just copied the main method from our DFS code. We will not have these things. Okay, so I will use the same graph instead of DFS. We will call the BFS. We need to send the graph start, target is 6, depth is not required here, shortest path. Okay, now let me just update the sysout message using BFS, and here I will add using DFS. Okay, now let me quickly run it here. So as you can see, the shortest path, I mean both of our solutions using DFS and BFS, they both return the correct shortest path. right? Now if we change our graph a bit, okay, let's say our graph would be looks like something like this, okay, this way. Let me change this 6, yeah, this way. So this graph, 0 is connected with 1 and 2, 1 is connected with 3, 3 is connected with 6, 2 is connected with 4, 4 is 5, and 5 is finally again connected with 6, okay. Now here if we starts with 0 and try our target, let's say 6 again. Now here also we can have two paths, right? So path 1 will be 0 1 3 6, 0 1 3 6 3, and path 2 will be 0 2 4, then 5, and then 6. So here the level will be 4. So ideally the shortest path for this graph to reach from 0 to 6 is of level 3, not of level 4, right? Now let me quickly update my input graph, okay, here. So okay, so now this is our graph input. Let me update it in BFS as well, the same graph input, okay. Now let me quickly run. So this is our DFS and this is our BFS code, right? Now as you can see, the DFS actually returns the shortest path as 4, whereas BFS returned it correctly, that is 3, right? Now here you can notice a subtle thing. DFS didn't fail because it's bad or it's wrong or its code is wrong. It failed because it is not meant for this solution. To find the shortest path of the unweighted graph, we should always choose BFS because DFS may find shortest path, but it doesn't guarantee, whereas BFS always guarantees that it will find the shortest path.
If this example made sense, let me move to the next mistake. Recursion is another area where good coders struggle. Not because recursion is hard, but because they forget where it stops. A missing base case means infinite calls. Stack overflow, program crash. In interviews, this isn't a small mistake. It signals that your code is unsafe. Interviewers care deeply about safety because production systems don't forgive infinite recursion. Now, let me quickly show a code example for this mistake so that you can understand the problem clearly.
So here I am using the factorial class. I will just write a simple code to find factorial of a given integer using recursion. Why factorial? Because it's the most basic class. In fact, I think all of us, when we first learned about recursion, we must have write the factorial code to using recursion, right? So that's why I choose factorial here. So let me quickly write a method, factorial method. So I will have it in static int factorial, okay, and it will have the number, and I will return the factorial. So factorial is nothing but num into the multiplication of all numbers from that number up to 1, right? So I will just go like this, okay. Now let me have a let me have a main method. From there I will basically call this factorial method, okay. Result equals to factorial of, let's say I want to find factorial of 5. Let me add system sys out. Okay, factorial, sorry for the typo, factorial of 5 is result. Okay, so I could have used a variable, integer variable in, initialized it 5 and then added in the log itself, right? Because my focus or my target is not to make you understand the code. I just want to show the problem number 2, which is missing base case in recursion, right? So that's why I just hard coded the message here. Okay, so let me quickly run this function. Okay, so here you can see we have some error, or you can say exception, runtime exception. What's the exception? That is stack overflow. Why stack overflow? Because we miss the base case in our factorial method, inside our factorial method, and that's why this method, since we are using recursion, it's getting called, keep on calling itself again and again, again and again, without any break, right? And that's why at the end it's throwing the stack overflow error exception. Okay, now if you remember, when I was writing the previous sample code for DFS, I specifically mentioned that when we write code using recursion, first the thing we have to, write is the base case. So for factorial program also, we have to write the base case as the first statement. Now what is the base case here? Base case is if num, if num given number equals to 1, then return 1, right? So this is the simplest base case. You can also add base case for 0. Okay, and you can also add some checks for negative numbers, but those are, I'm not doing those because I'm not here to, or my target for this program is not to make you understand the factorial code. My target is to make you understand the importance of base case in recursion, right? So that's why I'm just using the simplest base case, num equals to 1. Okay, now let me quickly rerun the program. Here, now you can see after adding the base case, we are not getting the stack overflow. The factorial method is getting breaked at the base case condition, and we are getting the correct value for factorial of 5, right?
Now, if you have ever felt confident after passing sample tests, the next mistake is very important. This is one of the most dangerous traps in interviews. Your solution passes all sample test cases, and you stop thinking. Sample tests are not there to validate your solution, they are there to explain the problem. Real evaluation happens on edge cases, empty input, maximum constraints, duplicate values, overflow scenarios. Interviews reward paranoid thinking, not confidence. Don't worry if the theory is too much for you. This sample code will make everything crystal clear.
Okay, so instead of writing a new code, let me use one of my existing code. Okay, so I already have a code to search any for target value using binary search. Okay, so this is my code, this is my function, binary search function. If you don't know what binary search is, or how to write the code, or what are the test cases, or what are the edge cases we should keep in mind, so for all those questions I have already created a dedicated video entirely for binary search, where I have explained how to write a proper binary search code, and how to take care, or what are the edge cases during writing the binary search code, and also during interview what exact terms you should look to identify that you can apply binary search here. Okay, so all those things, all those answers you can find in that dedicated video. I will share that video link in the description. Please do check that video. Okay, for now I will show you the test data here. So I have this array. I will use the same array everywhere. Now for this array, my target value is 1 for the first array, and sorry, 5 is for the first array and 1 is for the second array. And my expectation is when I give 5 as the target value, it should return the index 2, and when I give 1, it should return the index 0. Okay, now let me quickly run this program. Okay, so it ran for all the inputs I have given. Okay, now in interview or in your coding test, they might give you these two sample test cases, right, with this target and expected values. So once you see the sample test cases are passed, you may get relaxed, forgetting about the edge cases. Now let me show you what's wrong and how the edge case will fail. So let me just uncomment the third input. It's the same array, just that different target value. So here, just let me say here, the test array is same 1 3 5 7 9. Now my target value is 9, so my expectation is it should return the index 4. Correct. Now let me rerun this program. So here, as you can see, my third test case failed. Why it failed? It failed because we missed a small, or we made a small or minor mistake in this code, that is considering the edge case. So if you see this condition, while left less than right, now in the case where left is equals to right, where the target elements is the last element, this condition will not satisfy and it will break the while loop and we will return the -1. That's incorrect code, and that's the edge case that will fail for this solution, right? So just a simple consideration in mind and a simple fix will fix the problem. Okay, so let me save this. So we just have to check, instead of left less than right, we just have to check left less than equals to right. Okay, so I just made this fix, and let me quickly rerun this program. Yeah, so now you can see all our test cases pass and our test status is pass, right? So this is one small edge case that we should keep in mind during writing a solution with the binary search. For a detailed information on binary search, do check out the video which I will add in the description.
Let me talk about a mistake that is very small but extremely dangerous. Integer overflow is a silent bug. Your logic is perfect. Your algorithm is correct. But int has limits. Cross those limits and Java won't warn you. The program keeps running. The output is wrong. Interviewers expect you to anticipate this. Not because it's tricky, but because real systems fail silently. I will explain the mistake with a proper coding example.
Okay, to show you an example of integer overflow, I will not write too much of code. I will write simple calculation. Okay, so let me first write the void main method. Okay, and inside this main method, let me have two variables. One is low, which is initialized with, okay, let's start with a smaller. Okay, so which is initialized with 40, and in high is equals to, let's say, 60. And now we just need to find the mid of these two values. Okay, so mid equals to low plus high, which is our general formula to finding mid, right? Now system dot out dot println, here I will write mid value is equals to mid, right? Now let me run this program. So mid value is calculated correctly. 40 plus 60, 100 by 2 is 50. So everything looks fine, right? Now the problems arises here when the value of low and high is too big to find the mid, calculate the mid correctly. Okay, so for example, let me quickly give you a high number. So let's say our this is our number for low, and this is our value for low, and sorry, yeah, and this is our value for high. So as you can see, these are very high value integers, correct? And now if I want to find the calculation, so adding up these two values will actually cross the maximum limit of for integer, and it will result in overflow. How? So now let me quickly run the program. Okay, now as you can see, the calculated mid value is some negative numbers, which is obviously not correct because both the low and highs are positive. So adding those two positive numbers and finding the mid cannot result in a negative number. So what went wrong here? It's simple integer overflow. Okay, now to fix this, one option we have is to change the data type here. Another option we have is to change the calculation logic here. Okay, so if I can change the calculation logic just a bit, yeah, as you can see, now the calculation of mid is correct and it's returned the proper integer value in the mid, right? So keep this in mind. A small consideration will help us to avoid integer overflow during interviews.
Now let's talk about something that looks advanced but is often used the wrong way. Parallel streams look impressive, and many candidates use them just to sound smart. But parallelism has a cost: threads, context switching, synchronization. For small workloads, parallel streams are often slower. Interviewers don't reward fancy tools, they reward judgment. I know you are still not sure that the streams can outperform parallel streams. It's completely alright. The code example I will show you next will resolve all your doubts completely.
Okay, now please be with me when during the code completion I will show you how exactly parallel stream sometimes work slower than normal stream. Okay, so let me quickly write some methods here. Okay, uh, I will first have a data size just to show you how it impacts. Okay, so let me define it as final, which I will have this value. Now I will have, sorry, I will create the main method, and inside main method I will have list of integers, just some dummy data. This will be my dummy data upon which I will perform the operation. So let me fill the dummy data. I'm using int stream to fill the huge amount of data here. Okay, and I will fill up to data size dot box, then collect. Okay, so just for your understanding, let me just break it in multiple lines. Okay, so that you can read it in better way. Okay, now let me add some prints. Okay, uh, just for clarification, let me print our data size. Then let me copy this. I will print the number of CPU cores I have, right? I mean the processors I have. So level processors. Okay, I will use the runtime class. Yeah, so this will basically give me the available processors on my system. Okay, now one more sys out, and just print some dashes here. Finally, I will print not print anymore directly. Let me break the entire code in multiple sub functions so that we can have a clarity of the code. Okay, so uh, let me call the same function multiple times. So I will call the functions 3 times. Okay, so I mean I could have shown you, or you can see the difference in one time also, but just to show you that it will remain, the difference will be persistence no matter how many times we call the parallel stream or stream functions. Okay, now from here I will call methods. So let me create the methods first. Okay, so private void run stream. Okay, so and I will have this data here. Okay, so list of integer comma numbers. Okay, yeah, and I will have the start time. Mm, sorry. Then I will simply, let's say my objective is to find the prime numbers from this list. Okay, so all the count of prime numbers I will find. Okay, so count. Now I will use streams here. Okay, so stream dot filter. Okay, and filter in. I will create a function that will basically determine whether it's a prime number or not. Okay, and then once filter is done, I will simply get the count. That's it. And after that, I will also log the end time. So system dot nanotime, and Finally, I will calculate the duration of the execution. Okay, so it will be end minus start, and since this is in nanoseconds, so I will basically convert it into milliseconds. Okay, yeah, and let me just add a sysout to print the duration of the execution. Okay, sorry. Okay, uh, let me add few more values. Okay, so for example, count by stream, so that we can clearly identify which log is for stream and which one for parallel stream, right? And then mm, yeah, duration also, let me add the unit millisecond here, and I will just make a copy of this same method. The only change will be, instead of stream I will use parallel stream. Okay, okay, and also let me create the is prime method. Okay, oh sorry, let me add a static, otherwise I will have to create object to call the methods, right? And same for here. Okay, and let me place this method here. So I hope you all know how to check whether an integer is prime or not, right? Okay, so let me just add some conditions here, that if, okay, it's n, no problem. If n, okay, now I will write the simplest code. I will not, I'm not going to optimize the code and have a better time complexity, just to show you, because my objective is to show you the durations used by stream and parallel stream. Okay, so I will not focus on the optimization of is prime method or is prime logic, right? So I will simply use the brute force here to find whether the number is a prime number or not. Okay, so okay, so our code is ready for what we are doing. Okay, let me call run stream with the numbers, and also run parallel stream with numbers, same numbers. Okay, now what we are doing here, we are basically counting the prime numbers from a list of integers using stream and parallel stream. Okay, and we are logging the execution time, the duration taken by stream and parallel stream individually. Okay, so now let me quickly run this code. Just a second. Yeah, sorry, actually, I think I need to, optimize the isPrime method because it's taking more than expected time. So the video will be very long if I don't optimize the code. Okay, so just be with me. Let me quickly optimize the code here so that it will be much faster. Okay, and we can you can see the logs mm, much quicker. Okay. So instead of n, let me use math.sqrt n. Okay, and of course here instead of single increment I will increase it by 2. Now if you need an explanation that how why this work or how this is working, just let me know in the comment section. I will prepare a separate video where I will explain the time complexity and the benefit of optimizing your code with minimum change that will reduce the execution time exponentially. Okay, for now just see the code, and I will just run the change again, the updated code, to show you the parallel stream versus normal stream execution time. Okay, so as you can see here, all our three we are basically calling this run stream and run parallel stream 3 times. So we have 3 logs here, and every time you can see, sorry, let me update the log for a bit. Okay, now let me rerun so that you can see the difference. Yeah, so now you can see it's clearly visible that parallel stream is performing much faster than normal stream, correct? With the same data size, right? Now, so you will have a question that then how we are saying that parallel streams is slower, right? So slower in the sense when the task is not that complex, okay? When the task is very simpler and data is also very less, that time the due to the overhead of thread synchronization and context switching, the parallel stream tends to take more time than the normal stream. Now let me quickly make some change and I will show you. Okay, so let me quickly change the data size to 50,000. Okay, and instead of finding a prime numbers, I will simply find the count of even numbers. Okay, so let me just add a logic here, this. Okay, and let me update the same logic in parallel stream also. Okay, so we have reduced the data size and also we have reduced the operation. Okay, we have make it much simpler now. So instead of finding the prime number for each and every integers, we are simply checking whether that integer is even or odd, right? So now let me quickly rerun the program. Now you can see the stream for the same data set, the stream is taking 6 milliseconds, whereas parallel stream is taking 11 milliseconds. Okay, in some places stream is taking around 0 milliseconds, but parallel stream is taking more time than normal stream. Got it? So here, as you can clearly understand, the choosing of stream and parallel stream is very important. You should not choose parallel stream when you have very simpler tasks to perform on a comparatively smaller data set. You will only choose parallel stream when you have some complex operations and comparatively a large data set to perform.
If you connect all these mistakes together, you notice something interesting. None of these failures come from lack of knowledge. They come from assumptions. Assuming DFS is good enough. Assuming recursion will stop. Assuming sample tests are sufficient. Assuming int is safe. Assuming parallel is faster. Interviews don't fail you for what you don't know. They fail you for what you don't question. If this video helped you think differently about interviews, please like it. It really helps the channel. Share it with someone preparing for interviews. And subscribe to From Brute to Best if you want more content like this. If you have doubts, suggestions, or want me to cover a specific topic or algorithm, leave a comment. I read all of them. I'll see you in the next video.